Amides. Amides are a hydrocarbon derivative that contain a carbonyl group attached to a nitrogen. We can have primary, secondary, and tertiary amides, just like we did for amines. Depends on how many carbon chains are attached to the central nitrogen. To form an amide, you can react a carboxylic acid with an amine. We produce an amide and a molecule of water. But like esters, because we can use these two to form it, we use their names to name our amide. Okay, so to name, identify the portion containing the carbonyl group, and this becomes the root or the parent chain. This portion of the amide becomes the root. So to name this portion, identify the length of the carbon chain, and if this was an alkane, remove the E and add amide. So if the carbonyl is part of a 3-carbon chain, it would become propanamide. So 3 carbons, this would be propan, from propane, amide. If there's any side groups on this portion, they're prefixes to this root. So this is the root. If there's any side groups like a methyl here, you would identify the name and which carbon it's attached to, and that becomes the prefix for the root. Once the root is figured out, identify any other carbon chains attached to the nitrogen. So if you were a primary amide, you're actually finished. So again, you're going to add an N before naming the alkyl group, how many carbons it has, and identify the carbon chain. And if there's more than one, if it's a tertiary amide, then they become alphabetically. If it's tertiary and they're identical, then you put N and di. So if it's 2 ethyl groups, then it's N and diethyl. So let's name this structure. Here's our functional group. We've got an amide. So we have to identify the portion that contains the C double bond O, the carbonyl group. So it's here. The longest continuous carbon chain is 4 carbons. It has a methyl group as a side group. So the 4 carbons means that it's butanamide. So it's butane with an amide, butanamide, and we have a carbon attached to carbon number 2 of that 4 carbon chain, because the C double bond O is always number 1. So that's 2-methyl butanamide. And now we have to identify the other portion, which is right here. It's a 1-carbon chain. So this is N-methyl 2-methyl butanamide, and it is a secondary amide. Okay, so drawing. So identify the root from the amide. Draw out your carbon chain. And attach the nitrogen. If there's a prefix, attach to the root. Add the side group. To the root chain. If it was a primary amide, you're now done. And you'll see that there's no N-alkyl. But if there is, identify prefix with N-alkyl and add appropriate carbon chain to the nitrogen. Make sure nitrogen has 3 bonds on it. So if there's no N groups, it has 2 hydrogens, and if there's only 1 N group, it has 1 hydrogen. Okay, let's draw these structures. Propanamide. So we know we've got a 3-carbon chain based on the prop. And there's no N prefixes, so we know it's a primary amide. So 1, 2, 3 carbons attached to a double bonded O. So we've got a carbonyl with 2 carbons attached to it, attached to a nitrogen that has 2 hydrogens attached to it. Done. Then we've got this one. We've got 2 side groups. We've got an N-ethyl and an N-propyl. And then we've got our amide, which is 3 carbons long. So, again, our carbonyl is attached to 2 other carbons, giving us 3 carbons in our amide. And this is a tertiary amide because there's 2 side groups. One side group has 2 carbons attached, and the other carbon is, the other carbon chain is 3 carbons in length. So you need to add your H's. And your amide is complete, and it's tertiary. Okay, physical properties. The carbonyl group is polar, and if it's a primary or secondary amide, you've got a very polar NH bond. So you've got London dispersion forces, dipole, at the very least if you're tertiary, and if you're primary or secondary, you also have hydrogen bonding because of that NH group. So we've got high boiling points because these forces of attractions are quite strong. In terms of solubility in water, the primary and secondary amides can hydrogen bond with water, so are very soluble if they have a small number of carbons. And the tertiary is soluble because it can accept hydrogen bonds on its nitrogen. So if they're small, amides are soluble in water.